Hey guys, we're going to be starting a new unit today, and in this unit we're going to be talking about acids and bases. And you're going to have a PowerPoint to look at, you're going to have this video to watch, and then you're going to have an interactive notebook assignment to do. The interactive notebook is right here. There is a place there for you to put your name. What this is, you guys, and you may have done these before, I don't know. This is a Google Slides presentation. The only thing is that we're not going to actually present this, okay? We're going to keep it in this little mode right here where you can actually move things around and do things to it. So first thing you're going to want to do is put your name on there. Again, I have set this assignment so that it will make a copy of this for each one of you. So you will be the only one working on this presentation. And again, it's really not a presentation; it's an assignment for you to do. It's like a worksheet, but it's a a worksheet where you're going to be moving things around. So, and hopefully you've done this before, but if you haven't, then I'm going to just kind of give you a little bit of instruction here. So, for example, on this slide, you can actually click and type in the boxes. You can press enter and put your information there. And then on some of the other slides, you're going to actually be able to move the boxes around. So when you see that little plus like you see there, my cursor's a little plus, you can click. And again, you want to see the little plus, and you can just move that little thing around. And you can read the instructions on each slide, but it's going to tell you, drag things under the correct heading, match the things to each other, something along those lines. If we continue on here, this is going to be matching. These are terms, these are definition, match the term with the definition. On this slide, you're going to be you're going to be placing these different substances on this pH scale. Again, these boxes are pretty big, so you're not going to actually be able to put them in these little thin boxes. But what you can do is you can take my arrow here. You can, again, when you see that little plus, you can copy it. Then you can paste it, and then you can move it around. So let's say that I want it to be, I want to put something here for pH 11. Well, I can put that little arrow there. I can actually click on it. I can make it longer, and then I can put whatever substance that I want to be putting there at pH 11 there at the end of that arrow. So now there I'm saying, oh, colas are pH 11. Now, obviously, that's not correct. But, and again, for that slide, you can use, again, for all this information, you're going to use the PowerPoint. But you can also look some things up on the internet. Like for this one, I even told you may need to research on the internet to determine where the boxes should go. So again, right here, I'm saying, okay, colas are pH 11. Now, that's probably not correct, but I was just showing you how to do it. So again, you've got the arrows there that you can copy and then paste and make longer and shorter in order to place these substances on the correct location on that pH scale. Moving on, again, on this slide, it's telling you to put these boxes under the correct heading as far as classifying them as Arrhenius acids, bases, or Bronsted-Lowry acids or bases. Again, there's information on the PowerPoint as well as we're going to talk about that in a few minutes about how to do this. But again, some of these things could go under more than one heading. I tell you that here in the in the instructions. If you need to put those under more than one heading, then you can click on the box, make sure you see that plus, and then you can copy that box, then you can paste that box, and you can have another box to put under another heading. And then if there's anything you copy that you don't need, you can highlight it, click on it, and press delete. Again, I am copying and pasting by clicking on that box, making sure I see the plus, and then right-clicking, copy. And then I come down here somewhere, right-click again, paste, and then there's my box again. So, and then I can move it around where I want it. If I don't need it, I can delete, I can backspace, I can right-click cut or edit cut to get rid of it. This is another one where you're just dragging the boxes. This is a table where you're going to be clicking inside the box and completing information. Again, subscripts and superscripts, after you make your numbers or your pluses and minuses, like if I put H2O here and I want that 2 to be a subscript, I just highlight the 2, go up here to Format, Text, Subscript, and there you go. Now I have a little 2. So do that for me. And then on this slide, also on this one, I have an arrow up here. See how you need an arrow in the equation? Well, I have put an arrow up here for you. All you have to do is click on it, And then again, see the plus, right click, and again, you got to make sure you got the plus. Right click copy, and then I can right click paste, and there it will be. And again, you can click on it. You should be able to click on it and move it around. In any case, you may have to do a little bit of finagling with it. But anyway, so I'm going to try this one more time. I'm going to right click copy. I'm just going to click up here somewhere and put paste. And then, yeah, probably what you're going to have to do there for that one is after you copied this, so again, highlight it, right click come on, right click. And again, this may be a little bit frustrating. You may just want to go ahead and put the arrow in yourself. And I can show you how to do that as well, because I'm not getting this to work, and I don't know why. Because I had no trouble with it earlier, and now it's just like something else I wanted to show you that you can do, though. Why is it not wanting to do this for me? And this is the only thing about this. Yeah. This is probably going to take too long. There we go, copy. But if you get it copied, you can actually click outside the square and put paste, and then it will actually make the box. So if you're having trouble getting it copied and pasted, or getting it pasted after you get it copied, go over here outside the slide and click paste, and then you'll get your little text box. And then you can put it where you want it again, and then you can type on either side of it. So again, that's something I'm going to leave to you to figure out, because you may know a better way to do it than I do. But again, these are slides where you're going to be typing on them. This is another one where, again, you're going to right click on these. You're going to make sure you see the plus. You're going to copy them, and then you're going to paste it so that you have another box, and then you can go up here and put it. And what you're doing here in these equations is you are classifying each substance in that equation as an acid, base, conjugate acid, or conjugate base. And we will look at this in just a few minutes. I just wanted to kind of show you how to interact with these slides. Some of it might be a little bit touchy, but again, I know you guys are more tech savvy than I am, and you can figure out how to get it on there and how to get it to where I can tell what you're talking about. Okay? And then again, don't forget, when you're finished with all this, with this interactive notebook, don't forget to submit it to me, because that way I'll know that you're done with it. If you don't submit it, I'm going to think, okay, you're not done with it. All right, so we're going to start out with just in general what acids and bases are. We have just like a general definition of an acid. We have some properties and examples, and then the same thing for a base. So that information I'm not going to go over. You can read, but that's what you're going to use to complete this slide, and then also this one, that one. Okay, so a lot of that stuff you're going to be using to complete the first couple of slides on your interactive notebook. What I wanted us to look at are the different definitions, okay? So we have general definitions of acids and bases, but we also have more specific definitions of acids and bases. We are going to focus on the Arrhenius and the Bronsted-Lowry acids and bases. We're going to give the definition of a Lewis acid and a Lewis base, but we are not going to do much more with it than that. We're going to focus and use the Arrhenius definition and the Bronsted-Lowry definition. So we're going to look at Arrhenius first. The Arrhenius definition of an acid is anything that produces hydrogen ions or hydronium ions. This is a hydrogen ion. This is a hydronium ion. Now, these two are interchangeable. What a hydronium ion is, it is water, H2O, that has accepted a proton, which makes it H3O+. So when you take H2O and you add an H+ to it, you get H3O+, and we call this a hydronium ion. So we're going to talk about the H3O+ or hydronium ion a lot in this unit, but just know that these two, the hydrogen ion or hydronium ion, are pretty much interchangeable, okay? So anyway, just consider for Arrhenius, an acid is anything that can produce a hydrogen ion in solution. And then for an Arrhenius base, it is anything that can produce a hydroxide ion in solution. So pretty much these are the most narrow definitions of an acid and base. Acids have to have hydrogen ions in order to be an acid, and then bases have to have hydroxide ions in order to be a base. So let's use those two definitions. Let's look at this example. Classify each of these substances as an acid or a base according to the Arrhenius definition. So again, remember, acids produce hydrogen ions, bases produce hydroxide ions. So to be an acid, you have to have hydrogen ions. To be a base, you have to have hydroxide ions. So if we look at HNO3, obviously it has hydrogen ions, so it would be an acid. Letter B, KOH. Okay, obviously that has hydroxide ions, OH, so that would be a base. Letter C, CaOH2 has OH, hydroxide ions, so it's a base. D, HCl has hydrogen ions, so it's an acid. And then E, NaOH has hydroxide ions, OH ions, and so it would be a base. So again, the Arrhenius definition is pretty simple, and it is also pretty narrow. It is the most narrow of the three definitions. Moving on, Bronsted-Lowry, this is the one we're going to spend the most time with in this unit. An acid is a proton donor, and a base is a proton acceptor. So again, an acid, it's really a lot like the Arrhenius acid. It has to have protons. It has to have hydrogen ions to donate to be an acid, and then it must be able to accept protons to be a base. So anything that accepts a proton is a base, and anything that donates a proton is an acid. Okay, so here in this example, the HNO3 donated a proton and became NO3 minus, and so this means this was an acid. Okay, by the same token, where did that proton go? The hydrogen ion or proton that was donated by the HNO3 was accepted by the water, by the H2O, and it became H3O+. So the water is the base, because you can see here it accepted a proton. So in order to determine what's the acid and what's the base, it's easy if you have it in an equation, because you can see, oh, this HNO3 lost a hydrogen ion, so that was the acid. And this H2O gained a hydrogen ion, so that must have been the base. The water was acting as the base in that reaction. So again, anything that has accepted a proton is a base. Anything that has donated a proton is an acid. So acids donate hydrogen ions, or which we can also call protons, and then bases accept protons or hydrogen ions. So a base, now, so again, our definition of an acid is still, okay, you got to have a hydrogen ion, but more importantly, you have to accept, you have to donate those hydrogen ions. So if you have donated a hydrogen ion, you are an acid, and if you have accepted one, you're a base. So again, it helps to have an equation here. So if we look at this, NH3, and then afterward it is NH4+, then it accepted a proton. It accepted a hydrogen ion, so now it is a base because it went from NH3 to NH4+. So what this means is that water was, this NH3 was our base, and then here water was our acid. So if you notice here, water can do either or. Water can accept a hydrogen ion, or it can donate a hydrogen ion. In this example, it accepted a hydrogen ion, so it was a base, but in this example, it donated a hydrogen ion, so it was an acid. So therefore, water is what we call amphoteric. Amphoteric means that it can accept a hydrogen ion, or it can donate a hydrogen ion. Okay, and again, remember that things want to be neutral. So if you have a charge, it is because you either donated something or you accepted something, okay? So for example, here, this NH4+, obviously it has accepted something. So that NH4+, used to be this NH3. So the NH3 accepted the hydrogen ion to become NH4, so it is a base. The NH4 then would want to donate that hydrogen ion back. It would want to get rid of that hydrogen ion. And so it would act as an acid to get rid of it, because NH4 really wants to be NH3. Okay, so let's use those definitions to classify each of these as an acid, a base, or amphoteric. So we have NH4+ here. NH4+ is positive. Okay, it would want to donate a hydrogen ion to become neutral. So that would be an acid. Okay, H3O+ is also positive, meaning that it has an extra hydrogen ion that it would want to get rid of to become neutral. So H3O+ would also be a Bronsted-Lowry acid. H2SO4 also, okay? It is neutral. It could donate a hydrogen ion, and that's what it would do, so it would be an acid. And then H2O is amphoteric. We've already seen that. H2O can give away a hydrogen ion and become OH minus, or it can accept a hydrogen ion and become H3O plus. So water is amphoteric, meaning that it can act as an acid or as a base. So again, pretty much in any of these things that have these hydrogen ions, they could donate or accept, but again, if you are NH4 plus, then you are probably going to donate because you are already positive and it's going to be easier for you to donate to become neutral. If you are H3O plus, then again, you are probably going to donate because you're already positive, and if you donated, you would be neutral. So that's why those are acids. And then H2SO4, well, it's already neutral, so it's probably not going to accept a hydrogen ion. And again, we know this because SO4 is 2 minus. So two positive H's go with two negatives, go with the negative 2SO4. So it's probably not going to accept another hydrogen ion, but what it could do is it could donate one to something else and become HSO4 negative 1. So if you're already positive, you're going to donate. If you're neutral, you're probably going to donate as well. If you have hydrogen ions to donate, but not necessarily always. So again, it's a little bit harder to classify them as Bronsted-Lowry acids or bases unless you have that equation to go by. So let's go ahead and look at something that we call again, Lewis definition. Just know that definition. We're really not going to do anything with it. pH scale, again, that is just some information that you're going to go over yourself and complete the slide over it on the interactive notebook. And then Bronsted-Lowry conjugate pairs is what we want to look at now. Every acid has a conjugate base. Every base has a conjugate acid. So if the thing is the Bronsted-Lowry acid, then what it becomes after it donates that proton is going to be the conjugate base. Okay, so here we can see that this thing was HC2H3O2, and it became C2H3O2 negative. So it lost this proton, this hydrogen ion. So that means since this donated a proton, then it is an acid, and this would be its conjugate base. Then when we look at this thing, okay, H2O became H3O plus. It gained a proton. So then, or accepted a proton. So then this was the base because it accepted a proton, and this is its conjugate acid. So what it is before it does the gaining or losing is the acid and base, and then what it is after it does the gaining or losing is the conjugate of that. So again, C2H3O2 became C2H3O2 negative, so it lost a proton. It donated a proton. So this is the acid because it donated its proton, and this is its conjugate base. Likewise, H2O became H3O plus. So how did it do that? It gained a proton. It gained a hydrogen ion. So this means that since this gained a proton or accepted a proton, it is the Bronsted-Lowry base, and then what it became, the H3O plus, is the conjugate acid. Okay, so that is how you do conjugate acids and bases. Again, it's easier to tell what is your Bronsted-Lowry acid, what is your Bronsted-Lowry base, if you have this whole equation, because you can see, oh, look at this thing. This became this, so it got rid of an H, so that had to be an acid because it donated. This became this, so that had to be the base because it accepted. So this accepted and became this. This is the base, this is the conjugate acid, this is the acid, this is the conjugate base. And we're going to do some practice with that as well. So let's look at some practice problems here. Okay, so number 3, give the name of the conjugate base of each of the following. What we're going to do is we're just going to talk about what these would be. So if you have HCN, and we know that these are acids, so we know they're going to donate protons. So if we have HCN, and I'm not sure if I need to write this out for you or not. Just a minute, we'll see. Let me see if I can open this up and just a minute. Let me get it ready. All right. So what we're going to do first is I'm just going to go ahead and write these problems down here. That way we know what we're doing. So we're doing HCN. We are doing HSO4 minus. We're doing HF. And we're doing HNO2. Okay. So now I'm going to make this full screen. All right. So HCN, again, we know these are acids. And we know that acids donate hydrogen ions. And this is absolutely ridiculous. I don't really like this app at all. So I'm going to write the definition up here, just so that we have it. And then we had HCN. I know we had HSO4 minus. And what else did we have? We had HF. And we had HNO2. All right. So now, again, donate a hydrogen ion. So if you donate a positive hydrogen ion, then what you're going to end up with when you're done, again, you're going to get rid of that hydrogen ion and you're getting rid of a positive with that, so what's left is negative. So that's going to be Cn minus would be the conjugate base, okay? HSO4 is going to get rid of a hydrogen ion. So when it gets rid of that, again, not only is it getting rid of the hydrogen, but it's becoming more negative. It's getting rid of a positive. So that's going to be SO4 2 minus, okay? HF gets rid of a hydrogen ion and a positive. What's left is more negative. So what's left is F, and it's going to be -1. And then HNO2 gets rid of a hydrogen ion. What's left, again, is going to be more negative because it got rid of a positive, so it's NO2 minus. So what you have to do that conjugate base is you have to say, okay, this has a hydrogen ion. If it's an acid, it has to donate. It has to get rid of that hydrogen ion. So I take the hydrogen ion away, and I know that when the hydrogen ion goes away, a positive goes away with it, which leaves what I have left more negative by 1, okay? So the HCN becomes Cn negative. It donated that 1 positive hydrogen ion. SO4 negative becomes SO4 2 negative because it donated that 1 hydrogen ion, and it became more negative by 1. The HF became more negative by 1 and just became F. And then the HNO2, when it donates its hydrogen ion, what's left is NO2. And again, it's more negative by 1 because it gave away a positive. It's more negative by 1. Okay? So let's do the same thing then with our conjugate bases, these examples here. So again, the bases, according to Bronsted-Lowry, accept hydrogen ions. Okay? So our examples that we're going to do here, NH3, HCO3 negative, HS negative, and Br negative. All right? So again, here we have to remember that we are accepting hydrogen ions. So when we're done, we are going to be more positive by 1 because we accepted a positive 1. And so what we're going to do to these things is we're going to add a hydrogen ion, and its charge will increase by 1. So when you have NH3 and it gains a hydrogen ion, it's going to become NH4, and again it will be positive 1 because it gained that positive hydrogen ion. HCO3 negative is going to gain a hydrogen ion, so now it's going to have 2 hydrogen ions, and again it becomes more positive by 1, so it's just CO3 with no negative because we added a positive to it. HS negative, again, we're going to add a hydrogen ion, so it's going to have 2 hydrogen ions now, and it won't be that -1 anymore because we added a positive, so it's H2S. And then Br negative, well, if we add a hydrogen ion to that, it becomes HBr. And again, since we added a positive, it's not negative anymore. We added a positive 1, which canceled out that negative. So these are bases, and these are their conjugate acids. Okay, now something I want to point out to you here. Look at these two. I'm going to get rid of these two at the top, the one on the top and the one on the bottom. And I want us to look at, and again, I'm not getting rid of all of it because I want us to look at the two in the middle. All right. So let's look at HCO3 minus. HCO3 minus, okay, here we showed it gaining a hydrogen ion, but it has a hydrogen ion that it could lose also. So this could actually lose a hydrogen ion. If it lost a hydrogen ion, that would go away. It would become more negative by 1, and it would become CO3 2 minus. Okay? HS, we put it gaining 1 and becoming H2S, but could it lose 1? It has a hydrogen to lose. So HS could actually, lose a hydrogen ion. So if it lost it, then if it lost that, then it would become S2 minus. So these two can be either one. So HCO3 is amphoteric. It could be an acid or a base. Again, so could HS. HS is amphoteric. It can gain 1 and become neutral, but it could also lose 1 and become S2 negative, which is, this is the sulfide ion. This is the carbonate ion. So, be looking for those, if it has a hydrogen ion, but it's still charged, okay, it could lose that and become more negative, or it could gain that and become more positive. So a lot of these things could actually be amphoteric. Okay, so what I want us to do now is I want us to we already did those two. Let's see. Okay, so let's look at that one. It says give the name of the conjugate partner of each of the following acids or bases. So I'm going to write those down. SO4 2 minus, HI, S2 minus, and HNO3. All right. So here we're determining, are these acids or bases? All right. Well, again, remember, acids donate hydrogen ions, bases accept. Okay. So I'm just going to write that down here to remind us. Acids donate hydrogen, and bases accept. Okay, so when we look at this first one here, it doesn't have any hydrogen ions to donate, so it cannot be an acid. It has to be a base. And since it is a base, we know it's going to accept a hydrogen ion. So if it accepts, now notice here, since it's 2 negative, it could accept 2 hydrogen ions. It can accept up to 2, okay? So HSO4, because it accepted a hydrogen ion, and then it becomes less negative because it accepted a positive, so that's -1. So this would be the conjugate acid. So if this is the base, this is the conjugate acid. Okay, so let's look at the next one, HI. HI does have a hydrogen ion to donate, so we know that that's probably an acid. It's going to donate. And when it donates a hydrogen ion, it's going to get rid of the hydrogen, so what's left is I. And again, since it got rid of a positive, it's going to be more negative. So this is the conjugate base. And I'm just writing CB for conjugate base and CA for conjugate acid. Okay, S2 minus, again, does not have any hydrogen ions to donate, so it cannot be an acid. It has to be a base. And so if it's a base, we know it's going to accept a hydrogen ion. So if it accepts 1 hydrogen ion, We're going to add that hydrogen ion to it, and it's going to become less negative by 1. Now, it could accept another hydrogen ion here and become H2S with no charge. Okay, so again, but we're just going to give it 1 hydrogen ion. The last one here has a hydrogen ion to donate, so I know that it's probably going to be an acid because it can donate that hydrogen ion. When it donates that hydrogen ion's gone, and what's left is more negative because it got rid of a positive. So this would be the conjugate base. And again, this one is the conjugate acid. If this is the base, when it accepts a hydrogen ion, it becomes a conjugate acid. This is an acid. When it donates a hydrogen ion, it becomes a conjugate base. Okay? So now, last thing is we want to be able to label an equation. So we're going to do these 2 practice problems here. CHOOH plus H2O comes HCOO minus plus, and that should be H3O plus. Okay, and then the second one, H2S plus NH3 becomes NH4 plus HS minus. All right. So what we want to do is we want to figure out what is the acid, what is the base, what is the conjugate acid, what is the conjugate base. So to figure out what the acid and the base are, again, remember your definitions. Acids donate and bases accept. And these obviously are going to be hydrogen ions that we're talking about accepting and donating. Okay, so here's the CHOOH. Okay, what did it become? It became this. Okay, how did it become that? Well, it looks like it lost this hydrogen ion at the end. So if it lost a hydrogen ion, then it donated a hydrogen ion, so that is our acid. And then this would be our conjugate base. Okay, because your acid has a conjugate base, your base has a conjugate acid. Okay, so the acid is what it was before it donated. The conjugate base is what it is after it donated. Okay, so then this means that this water has to be our base. Let's make sure bases accept. So did water accept a hydrogen ion? Yes, it did. To become H3O plus, it accepted a hydrogen ion or a proton. So then this means that water is our base. And then this H3O plus is our conjugate acid. Okay, so to come up with your conjugate acid, you have to take your base and add a hydrogen ion to it. Okay, the next one, H2S, what did it become? Well, it looks like it became this. Okay, H2S became HS. So what did it do to become HS? Well, it got rid of a hydrogen ion. Okay, it's missing one. Here it has 2 H's, here it only has 1. So since it got rid of or donated a hydrogen ion, that is our acid. And the HS would be our conjugate base. So then this means that our ammonia, our NH3, must be our base. Let's make sure. In order to be a base, it has to accept a proton. Did it accept a proton? Yes, it did. It had 3 H's, now it has 4, and it's positive 1. So this is our conjugate acid. So again, the acid is what it is before it donates the hydrogen ion. The conjugate base is what it is after it has donated. The base is what it is before it accepts the proton. The conjugate acid is what it is after it accepts the proton. So I hope this helps you out with what you're going to need to do on your interactive notebook. Please let me know if you have any questions. Again, I'll be happy to answer any questions that you have. This is going to be something where you're going to have to be writing the equation. So again, if this is an acid, then it needs to donate a proton to become a conjugate base, and that's probably what I should say there. So anyway, what you're gonna do is you're gonna show the H3O PO4 and then put your arrow and then show it donating a proton and then plus and then what it is after it donates the proton, which is the conjugate base. Okay. And I'm going to go ahead and put conjugate there because that's what it is. All right. And then For some of these, it gives you the conjugate base. So what does that mean? If it's a base, it has to accept a proton. So if this accepted a proton, what would it become? And then you have to show the equation for that. If this accepted a proton, it would become HF. So you would put HF here, and then your equation would be HF, and then your arrow, and then H plus F minus. Okay, so again, use this one. This one is done for you. This is a guide for you to go by. For this one, I also did the first one for you. How do I know this was an acid? Well, let's look and see. NH4 plus became NH3, so that means it donated a proton, so that has to be my acid. That's my conjugate base. OH minus became H2O, so this means it accepted a proton, and so it's a base, and that's my conjugate acid. Okay, so look at what it was before, look at what it was after. Okay, and you can see which one donated and which one accepted. The one that donated is the acid, and then what it was after it donated is the conjugate base, and then the one that accepted is the base, and then what it was after it accepted is the conjugate acid. Please let me know if you have any questions. I hope you have a great day, and we'll talk to you later. Bye-bye.